Lesson 13, differentiating between GCF and LCM. And notice here, it says to see page 8. So let's go ahead and take a look at page 8 now. And here it is. And this is the reason that we have this page. Now that students know about GCF and LCM, one thing that they often struggle with is telling the difference between the two and knowing when to use one versus when to use the other. It's really easy for students to mix these two concepts up, and that's why we have a system in place to make things clear. And here's the system right here in the little circle. It says GCF and LCM look different from each other, and it's that simple. If students can remember what these two different types of problems look like, they'll intuitively know when to use GCF and when to use LCM. Let's start with GCF. GCF, or greatest common factor, is only used for simplifying fractions, and this is what those problems look like. Here, we have a fraction with a numerator and denominator, and these are the two numbers that you'll be working with. Take a look at the numerator and denominator, and you can think of these as Notre Dame problems, just like I have it written here. Notre Dame is a well-known university, and when you think of Notre Dame, you think of Great College Football, or GCF. And that's why when you see a Notre Dame problem, you should think GCF, or Great College Football. When finding the GCF, always list factors vertically, just like we have it shown here. And the reason for this is, when you look at the numerator and denominator, those are also listed vertically. Let's move on to LCM. LCM, or lowest common multiple, is only used for adding and subtracting fractions. And this is what those problems look like. You have one fraction plus or minus another fraction. And these are the two numbers that students will be working with. Take a look at the denominator and denominator. And you can think of these as double Dutch problems, just like I have written here. And when you think of double Dutch, you think of little children moving, or LCM. And that's why when you see a double Dutch problem, you should immediately think LCM, or little children moving. When finding the LCM, always list multiples horizontally, just like we have it shown here. And there are two reasons for that. Here's reason number one. When we're working with adding and subtracting fractions, we're first going to use problems where the denominators appear horizontally. And that's why you want the multiples to go horizontally as well. Here's reason number two. We're going to list multiples horizontally, just like this, so that it looks different from GCF, which lists factors vertically. So by making GCF and LCM look different from each other, we help students intuitively understand the difference between the two, and we prevent them from mixing the two concepts up. Here are the practice problems for Lesson 13, differentiating between GCF and LCM. This lesson is unique because it involves not just written responses, but verbal ones as well. Take a look at instructions 1 and 2. Here, students need to verbally and instantly say whether each problem is a Notre Dame problem or a double Dutch problem. And students have to verbally and instantly say whether to use GCF or LCM to solve the problem. And this is what it looks like. In box A, we have the fraction 8/10, and these are the two numbers that students will be working with. 8 is a numerator, 10 is the denominator, so this makes this a Notre Dame problem. Look at box B, 1/2 plus 1/3. These are the two numbers that students will be working with. 2, which represents halves, is a denominator, and 3, which represents thirds, is also a denominator. And this makes it a double Dutch problem. So students have to go through all the boxes verbally and say whether it's a Notre Dame problem or a double Dutch problem. And this is how quickly it goes. Here, Notre Dame, double Dutch, Notre Dame, double Dutch, Notre Dame, Notre Dame, double Dutch, Notre Dame, double Dutch, Notre Dame, double Dutch, Notre Dame, Notre Dame, double Dutch. And students have to be able to do it that quickly because it ties in directly with GCF and LCM. In step 2, we go through each problem and identify whether it's a GCF problem or a LCM problem. So here, when I think of Notre Dame, I think of great college football or GCF. Here, when you think of double Dutch, I think of little children moving or LCM. And this is how quickly it should go. GCF, LCM, LCM, GCF, LCM, GCF, GCF, LCM, GCF, LCM, GCF, LCM, LCM, GCF, GCF, LCM. Notice how quickly that went. And when students get to that level of fluency, it means they intuitively know the difference between GCF and LCM, and they won't mix them up. Once students have gone through that verbal exercise, then they go on to direction number 3, which is to simplify or solve each problem using GCF or LCM. Let's go over 2 examples, box A and box B. Here's box A. Here we have 8/10, and these are the 2 numbers that students will be working with. We have a numerator and denominator. That makes this a Notre Dame problem, and we're going to look for the GCF. So let's use the magic question first. Can you do 10 divided by 8 evenly? The answer is no, so let's use the shortcut. Don't list factors of 10 and factors of 8. Only list the factors of 8, the smaller number. So we have 1 and 8 and 2 and 4. Just like in real life, start at the bottom and work your way up. 10 divided by 8, can we do that evenly? No, so cross it off. 10 divided by 4, no, cross it off. 10 divided by 2, yes, circle and star, that is our GCF. If students are able to find the GCF of 2 without having to list the factors, that's fine because they're able to do it in their head and they're saving a lot of time. Next step, write divide by 2 and divide by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Box your final answer of 4/5. Also, if students don't want to write divide by 2 and divide by 2, and instead they want to cross off and say divide by 2, that's perfectly fine as well. So they can do this. Say divide by 2, divide by 2. What is 8 divided by 2? That gives you 4. What is 10 divided by 2? That gives you 5, and you get the same answer. Here's box B. 1/2 plus 1/3, and these are the 2 numbers that we're working with. We have a denominator and denominator. That makes this a double Dutch problem, so we're looking for the LCM. Use the magic question first. Can you do 3 divided by 2 evenly? No, so we have to use the shortcut. Don't count by 3 and count by 2. Just count by 3, which is a larger number. Here we go. 3, stop. Can you do 3 divided by 2 evenly? No, so keep counting by 3. Next is 6, stop. Can you do 6 divided by 2 evenly? The answer is yes. Circle and star. And 6 is our LCM. If students are able to come up with 6 as the LCM without having to list the multiples, that's fine to do because they're being efficient with their time. Let's rewrite the problem, and I'll use the next line. Equals blank over 6 plus blank over 6. 2 times 3 gives us 6, so write times 3. Do it in the numerator as well. How did we get from 3 to 6? times 2. Write times 2 in the numerator as well. Now everything becomes just a simple multiplication problem. 1 times 3 is 3. 2 times 3 is 6, and it's already there. 1 times 2 is 2. 3 times 2 is 6, and it's already there. Now just think apples plus apples. Sixths plus sixths give us sixths. How many sixths? 5 sixths. And box your final answer. And we're done.